4 lower half. That's actually, there are 4 parts for the semicircles with exercises. So in this case, it is lower half circle. So I want you to look at this exercise before you watch the video. Try to write down the formula, the main, range and center, as well as the radius for each function in the image. And then, when you are sure that you are okay with this, you can look at the answer sheet. If you are not sure, you can either look at the answer sheet or you can watch the video. Let us look at the red graph. This is the g of x here, and we see that if I look at my green graph, which is now minus square root of 9 minus x squared with a radius of 3, then first of all, I know my red doesn't have the origin as center, so it has shifted, or you can see it shifted to the right. So let us look at the left endpoint. The left endpoint there is the point minus 1, 0, and on that side it is 5, 0. So if I look at the radius, I will get 5 minus 1 divided by 2, that gives me 6 over 2, that gives me 3. So I've got a radius of 3. The center, if I now add 1, 2, 3, then I get to that point there, and I'm going to use red. So x is 2 and y is 0. So my center is 2, 0. So that means that my h is 2 and my k is equal to 0. I can now write down the formula. Let us do it. So I know I've got the lower half, so there must be a minus before the square root. So the radius is 3, so I write 9 minus x minus 2 squared, and I don't write the plus 0. So that is my equation for my red graph. So the domain from the graph, we see it starts at minus 1 and it ends at 5. And the range, it starts at negative 3 and it ends at 0. Again, I can look at this x minus 2 here, and for the regular green graph, that should be less than or equal to 3, greater or equal to minus 3. So if I solve for x, I must add 2 everywhere. Then I get x is less than or equal to 5, greater or equal to minus 1. This is if you do not have the graph, then you will go that way. Let us look at the purple graph. Again, this is the graph t of x. So if I look at the endpoint there, I get x is minus 1, y is minus 3. If I look at the right endpoint, I get x is 5 and y is minus 1. So my radius will be 5 minus 1 divided by 2, which is 6 divided by 2, which is equal to 3. Exactly the same as that of the green and the red graph. The center, if I now go 1, 2, 3 units there, then I will get the point x is equal to 2, y is equal to minus 1. So the center will be 2 minus 1. Therefore, my h is equal to 2 and my k is equal to minus 1. So I can then write down my formula. First of all, it's a negative square root because it's concave up. I've got 3 squared, which is 9, minus x minus 2 squared, minus 1 outside the square root. And then my domain will be, if I do it from the graph, it will be from minus 1 to 5. So let us look at the range. The smallest value here, minimum value here, is at x equal to 2, y equal to minus 6. So the range will be from minus 6 to minus 3. So the purple graph is the green graph because it's got the same radius as before. It's the green graph shifted 2 units to the right and 3 units down. I see I carried on the mistake here. That was a minus 1, it should be minus 3, so that is also minus 3. So it's 3 minus 1. So the center should be minus 3, and the k should be minus 3, and the dig should be minus 3 there. Sorry for the mistake. Okay, so again, when I do not have my graph, I can say that this x minus 2 should be less than or equal to 3, greater or equal to minus 3, because it's a shifted green graph. So then I will add 2 everywhere, so I will get x less than or equal to 5, greater or equal to minus 1, which is exactly the same as for the red graph, but now we can also say the purple graph is the red graph shifted 3 units down. Let us look at the brown graph. First of all, if I look at the endpoints here, I get the value minus 5, 3, and you can zoom in on the graph to get that values. Then on the right hand side I get x is minus 1 and y is equal to 3. So my radius will be minus 1 minus minus 5 divided by 2. That gives me 4 divided by 2, which is equal to 2. So my radius is now 2, and you can see that it is not as wide as the other 3 graphs. So to get to the center then, I will either come from the left, count 2 back for the radius, and then this center of mine will be then at minus 3, and the same value as the other y values, because they all lie on the same horizontal line. So my center is minus 3, 3. I can write down then my h is equal to minus 3, my k is equal to plus 3, my k is equal to plus 3, and then my equation is y equal to negative square root of. I've got a radius of 2, so 2 squared is 4 minus x minus minus 3 square plus 3. So that gives me minus square root of 4 minus x plus 4 square plus 3. I specifically write that step to remind you of the formula, which is x minus h. It's not x plus h, it's x minus h square, or square minus plus k outside. So, and then it is easy to see where does the graph move, whether it's left or right. So I see I made a mistake here. This should just be plus 3, and then, so what is the domain? From the graph I see it goes from negative 5 to negative 1, and the range will go from 1 to 3. If I do not have the graph, I know x plus 3 must be less than or equal to 2, greater or equal to minus 2, because we have a radius of 2. We have a radius of 2, so the radius is like that. So now I must subtract 3 everywhere, so I get minus 5 less than or equal to x less than or equal to minus 1. And that is exactly the same as we had in the square brackets, minus 5 minus 1. So that we can write it as the set of all x's such that x is like that.